Nintendo Switch. In this case, all I know about it is no power. So the first thing I kind of want to do right now is take a look at the port and see if there's anything going on in there. I see some fuzz of some sort. See if we can carve that out of there. Just want to make sure there's nothing going on in the port before I plug power to it. See if I can get in there. Get that fuzz. There it is. And it's just fuzz of some sort. Other than that, I don't see much going on here. Just want to make sure there's nothing conductive before I plug in power. Alright, let's flip you back over to me. Apologies that you're getting more of me. Alright, let's plug some power to it and see what it's doing. Okay, we're getting a point. Okay, this is not supposed to be power. Don't tell me that fuzz was killing it. Okay, I'm going to pause this and see if it charges and see what happens. We'll be back. Okay, we're back, and the Switch is definitely doing something weird. I had it on the OEM and it was charging fine for a moment, but now it's dropped to 0 current draw. On both sides. So my guess is we probably have an M92 T36 issue. It seems to be intermittently working. So what we're going to do is we're going to disassemble enough to look around and do some initial testing around the M92 T36 and go from there depending on what we find. Okay, we had the Switch completely out of the housing. For some reason I just decided to do that, and sometimes the brain just stops working and you just go into auto mode. We need to not be doing that for the rest of the spare, so let's get to testing. We'll switch you to microscope. We're going to test around the M92 T36. As always, we will follow the traces to the chip. We're going to check the capacitors around it, and we're going to follow the traces to the chip. In this case, this chip goes through M92 T36 and connects over to Pi 3 USB on the other side. So we want to test it and make sure it's good. On this side going to the chip, and it's good. So the rest of them we want to test the same way, following the traces. Okay, and follow the traces. Okay, in this case we have 2 traces going to the chip. So one side on the capacitor will always be ground. So one of those sides is going to be grounded, which is that side. Our CPU cap seems okay. Check our MOSFETs. Check our filter. Jump up here and check our invincible fuse. Still being invincible. Now we're going to check our test pads. This one should be ground. And you can't see it. And as always, my focus is not the same as my eyes. Someday I hope they come up with a better solution for this. Okay, that one should be ground. None of these in this area should have any pathway to ground. Looking good. Check our 2 test pads over here. None of these should have a pathway to ground. Now we'll check our coil. Good. I'm going to check the capacitors around BQ2493. Same rules apply. If it has 2, one of them is going to be ground. I generally know what side to check, so I'm not checking the ground sides. Okay, now we're going to finish checking our test pads. One of these is going to be ground. One of them is not. That one's not. This one is. Okay. Now we have done a visual inspection. Sometimes when you run into intermittent problems like this, it could be these max three-phase buck regulators, but there is no liquid or anything. Everything looks fairly pristine. So, I'll flip it over. Kind of have ourselves a look around here as well. And I'm seeing nothing but some dust particles. That's fine. Alright, so let's check Pi 3 USB because, again, if you're getting 0 amp draw, it can be Pi. But typically it would be like 0.47 or something of that nature on the 5 volt PSU anyway. 0.21 on a OEM. Okay, we want continuity straight through. We do not want it side to side. And yeah, of course you're out of focus. Because why not? Now don't get trolled. Sometimes these can have some manufacturer residue still on them. Flux residue typically. And it can be a little difficult to get through it. And it can troll you into thinking something is wrong that's not. Alright, now we're going to do the same thing. We're going to follow the trace from this big capacitor to the chip. And we're going to check it. And looking good. Alright. So we have nothing obviously wrong. And we have nothing presenting in a way that would make you think it's short. So at this moment, just as an educated guess, I am thinking our M92 T36 is failing gracefully. So what I'm going to do is change it out based on this theory. And it's just a theory because I don't have anything that is really telling me otherwise, except I do have one situation on the OEM charger. It was pulling 15 volts at one point and charging, and then it dropped to 5.1 and 0 amps. So typically speaking, if you test, and this is why we in the industry tend to suggest that you have an OEM charger on hand. Depending on the fault, if you are getting communication with the M92 T36, you should be drawing 15 volt. If you're not drawing 15 volt, if you're only drawing 5, then something is either wrong with that chip or something in between the port and the chip. If you're not getting 15 volts, regardless of whatever fault, Pi 3 USB, the buck regulators, gas gauge, it doesn't matter. You should be, if you're getting communication with M92 T36, at least in my experience, you should be drawing 15 volt, even if you're not drawing amps or anything else. And that is the chip communicating with the charger, telling it what voltage to send. So, the fact that it dropped to 5.17 volts or whatever it dropped to is telling me there's some issue here or in between, and we see no issue in between. So I have to believe, I'm left to believe it's going to be that. So we're going to pull that chip and we're going to put another one on, and hopefully that will solve the issue. While I'm setting up my equipment, let me throw up my temperatures. Disregard the lows on that because I was working on an orange screen of death and I did have to drop temperatures on that, and I just didn't get around to change it. So I don't expect to be using the lows on that, either airflow or temperature. I also don't expect to use, well, I probably will use the Pico pencil to clean up after placing the chip. So usually end up having to do that because we squish solder out from below the chip. Okay, we'll switch to microscope and we'll remove the chip and put a new one on. We're not going to stop the test because there's nothing presenting. So we're just going to pull the current chip. We're going to put a new chip on and then we'll test afterwards. Okay, so let's perform a quick test and see what kind of behavior we're getting now. Does it look like something resembling normal, or are we still getting 0.00? That right there says we're still getting 0.00. What in the... Okay. Why are we still getting 0.00? I don't feel like we should be still getting that. So we have a port problem, disguising itself as an M92 T36 problem. Or if we just put a dud chip on. Not getting any change here. This is very strange. Let's try our OEM with the meter. I don't know if I can get you in a way that you can see this. Maybe without the light. Yeah, we're getting stone cold nothing now. We're at least getting something with their chip. So I think we may have a dud. Did I put this chip on the right way? I swore I did. But you know what? I totally did not. I did not. I put it on the wrong way. Wow, that's a first in a long time. Great job there, Josh. I don't think this is going to work now that we put it on the wrong way, but let's try changing it to the right orientation. So highly suggest, high probability we just killed it. The chip. Before we plug power to that, let's test around it and make sure we did not add a short that will kill CPU. It's okay if we kill the chip, it is not okay if we kill CPU. Should be getting ground on one of those sides. There we go. Has me concerned I wasn't getting readings. Okay. Does not appear I've killed it in a way that will kill CPU, so let's try again. I won't bother cleaning up just yet. I suspect we're going to have to change that chip. Okay, that's kind of normal. Kind of normal. Let's throw our OEM on there just so we can see if it's actually giving us the correct voltage. Again, we tried to kill the chip, so now we're getting 14. Kind of what we expect. Let's throw our battery dongle on. Find the battery. There it is. No. There it is. Turn that channel on. We'll be watching channel 2. And we'll activate with the OEM and see if we're booting. We want a steady climb. We don't want to be hung up anywhere. And it seems to be booting. So somehow, even plugging power to the chip in the wrong orientation, it appears we were lucky enough not to kill it. I'm not going to, stamp that just yet, final as a final resolution just yet. But so far, it looks like we didn't kill it by some miracle. So, next step, clean off the board, and then we'll reassemble enough to test. This time, just enough to test, because we're going to stop being brain dead here at some point, or I'm going to get unreasonably upset with myself. And then we will perform some tests and see what happens from there. Okay, we are prepared to test with my known good battery. And let's see if we can get it to boot up now. Okay, full battery symbol, that's a good sign. Resetting. Fast charging. Okay, let's pull it. See if we're charging on the other side. And we're fast charging on the other side. So we did manage not to kill the chip. Somehow we got very lucky. Do not do that. Do not put it on in the wrong orientation and then expect it to work. Anyway, we're going to power it down. We're going to reassemble entirely. And then we'll run it through a few more tests, make sure it's charging Joy-Cons and everything else that it should be. And go from there. Okay, and as you can see, we are docking. So everything looks pretty good. We'll switch you to capture. Awesome. We are charging the Joy-Cons as well, just in case I recorded the whole last part without audio, because that's been how this whole repair has gone. So we're charging on both sides. We are charging the Joy-Cons, which you will see in just a second. Get it in there. Okay, we're charging both Joy-Cons. Very good. And we're docking. Didn't really have to do a dock test, but we did. And I did test the game cartridge reader. I don't know if I got that on camera or not, but everything's looking good. Okay, in summary, we had a Nintendo Switch that appeared to be charging when we cleaned out the port. There's some fuzz in the port. But it intermittently stopped, and while we had it on the OEM charger just to charge it up to enough to boot, it went to 5.17 volts at 0 amps, and then when we put it back on the PSU, we're drawing 0 amps. So that's usually indicative of something going on with the M92T36. That could be your fuse, that could be the M92T36. That's generally, or like the far right filter on the Pi 3 USB can cause that. Generally speaking, if the Pi is bad, you're getting some sort of current draw, or if you're getting issues with the 3-phase buck regulators or the gas gauge and stuff like that, you're getting some sort of current draw. Anyway, we pulled the chip, we put a new one on incorrectly because I am brain dead and apparently I need to call it a night. So we figured that out. We actually applied power to the chip, which for somehow did not kill the chip. I'm still pretty shocked that it didn't kill the chip, and we luckily didn't kill the switch. Anyway, we put it back on in the right orientation. Everything seems to be fine. I'll definitely check it up on it again in the morning just to make sure. But everything seems to be working fine. It's charging both sides, it's docking, it's recognizing the Joy-Cons, it's charging the Joy-Cons. Everything seems to be good. So, as docking, like I said, yeah, everything seems to be good. So, anyway, I think that's it for this repair. Like I said, I'm going to call it a night because I'm clearly, my brain is checked out tonight. So, it does happen. I don't know why. It's not like it was some sort of brain strenuous day, or I mean, I've gone through a lot of repairs today, but anyway, we apparently did not save the brain power for later. If you have any questions about the equipment I used in this video, take a look in the description below. They're all linked down there. It's all Amazon affiliate links now, so even if you don't buy some of the equipment, if you want to support the channel and you decide you want to buy something on Amazon, just click one of those links and then buy whatever you want to buy. We still get a piece of that purchase, so, and I would appreciate it. There's also some other support links in the description if you want to go that route. If you like the video, do me a favor and hit the like button. And if you want to see more videos like it, hit the subscribe button, notification bell. You'll know when I post videos, usually about twice a week. If you have any questions, please feel free to post them in the comments below. I like questions, and I try to answer those questions when I can. If I can't, I try to direct you to somebody who can. That's really all I had to ask of you. I appreciate you watching, and we'll see you next time.